We're going to finish 7.1 today from what we had finished in class. So remember, 7.1 is doing the antiderivatives. We have to always put a plus C unless they give us more information, because there's always going to be a constant there we have to assume. Power rule, remember we're going backwards, so we add 1 to the exponent and divide by the new exponent, which is what's written on the top of this page. And then if we're dealing with the base E, remember we would have, again, this is specific, it has to be kx in the exponent. We would have kept it, and we would have multiplied, so now we're going backwards. We're going to divide by that derivative of the exponent, so it will always be k in the denominator. So e k to the x over k. For 1 over x, we're going backwards, remember? So the derivative of natural log of x was 1 over x. We're going backwards, so it's natural log absolute value, because we have to be worried about that domain piece. So we're going to start with number 10 now. And remember, you only have 3 rules, 3 options. So I am taking the antiderivative of each piece separately. So antiderivative of e to the tu, we keep it, and then we again divide by that coefficient of the exponent. I would put a plus c, but I'm going to put it at the very end. For the second piece, I'm going to use the power rule. So the 4 doesn't affect it. We add 1 to the exponent, remember there's a 1 there, and divide by our new exponent. So my final answer here, 1/2 e to the tu plus 2u squared plus c. That is my answer. Pause at any time you need to. So on number 11, I do not have a chain rule right now, so I need to go ahead and get rid of that exponent on the outside, which means I need to multiply it out. I need to FOIL it out. So remember, that would have been 9x plus 3 times 9x plus 3. So that gives me 81x squared plus 27x plus 27x plus 9. So I actually have 81x squared plus 54x plus 9, taking the antiderivative with respect to x, which is what this part here tells me. So I'm going to do each piece separately using the power rule. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Remember to always add the c at the end. So now we simplify. 27x cubed plus 27x squared plus 9x plus c. Remember, you can always check this super quick by taking the derivative of what I just circled in green, and make sure that you get what you started off with. So now we're going to deal with problems that are asking you to do a little bit more. They give you a little more information. When they give you a little more information, it's so that you can get rid of the c in the problem. So we're going to start off first, again, finding the antiderivative, just like we were doing before. So I'm going to integrate 8x squared plus 5x minus 3 with respect to x. And then remember, this original one was f prime, so my new function will be f of x. Add 1 to the exponent, divide by the new exponent. So up until now, we've just had to put the c there. But because they gave us that 0, 8 is on the actual curve, we can plug this in to figure out what c is. 8 is my y, 0 is my x. So 8, this becomes 0, this becomes 0, this becomes 0, plus c. So 8 is equal to c. Don't assume that's always the case. Please make sure you double check when you plug in. So my equation is f of x equals 8/3 x cubed plus 5/2 x squared minus 3x plus 8. The extra point gives us enough information to figure out what C is by plugging it in. Again, pause at any time you need to. So 13, we're finding the equation of the curve whose tangent line has a slope of x to the 2/3. Remember, that's the derivative, and they give us a point. So to go backwards, we want the equation of the curve. We're going to take the integral of x to the 2/3 with respect to x. So I'm going to use my power rule, which says add 1 to the exponent, so 2/3 plus 1, which gives me 5/3. And then I divide by that new exponent plus c. So I have x to the 5/3, and remember when I divide by a fraction, it basically means flip it and multiply. So that gives me actually 3/5 x to the 5/3 plus c. Now I'm going to use this point they give me. I'm going to plug that in to my equation. 3/5 is my y. 1 is my x. 1 raised to any power is 1. So I have 3/5 equals 3/5 plus c, which means c is equal to 0. Because if I subtract 3/5 from both sides here, they're going to cancel out. So my equation is, again, I'm coming back to here to plug it in, 3/5 x to the 5/3 plus 0. So we're not actually going to write anything there in that case. That is my answer. Now if you put a plus 0, it's not going to be wrong, but it's just not the best format to write your answer in. So now we're going to go to some word problems with using our revenue, cost, functions, profit. And so these are some reminders. Fixed cost means that if I were to plug in 0, meaning you haven't produced anything, that's going to be your constant. So your fixed cost will actually end up being your C. Stop and think about revenue. When you do not produce anything, you should have 0 revenue. So this is another point we're going to use. And so using those two together, profit is equal to revenue minus cost. So this is where you got to be careful. You're going to have a minus the fixed cost. Okay? The fixed cost will equal the constant in your cost function. Initial revenue is 0, which means your constant in the revenue function will be 0. Because I subtract these two to find my profit, my C for my profit function should always end up being minus my fixed cost. These should end up being able to be reasoned out as you do a problem. So we're going to read number 14. We have a cost, the derivative of a cost function, and we have the fixed cost, so find the function. So we're going to start off by integrating with respect to x. So c of x is equal to, again, add 1 to your exponent, divide by the new exponent. Add 1 to your exponent, divide by that new exponent. We always have a plus c starting off, but because my fixed costs are told to me as being $10, that's my c. So my final function here, you are kind of expected to simplify this, meaning that you have a decimal and a fraction. So if you took your calculator and took 0.2 divided by 3, you're going to see that you get a decimal that rounds, and you don't want to use that. So this is where you would want to use your fraction key to convert it back to that form. And you should get 1/15. All I did was 0.2 divided by 3 in my calculator, and then I used that fraction key to convert it back. If it was an exact decimal, I'd be okay with it, but it's not. So we don't ever want to leave a decimal and a fraction in the problem. The 10, again, is my fixed cost. That is my answer. If I wanted to check this, super easy to check. Take the derivative. Remember, you'd bring down the exponent. This would be 1/5 x squared. And I'd bring down my exponent, and that would give me a 5x, and the constant is gone. And if you plug that in your calculator, that does actually match. Going to number 15. Again, I have a derivative of my cost function. So I'm going to take the integral. And it's telling me, it doesn't give me the fixed cost here, but it does give me a point where I have the quantity and the cost. So I'm going to use that to find my constant term. So I'm going to take the integral here first. Remember, we add 1 to our exponent, which is 3/2, and then divide by that. When I have a division of a fraction, it means to flip it. And now I'm going to plug in the point 1645 into this function to evaluate for C. (16 to the half power) says the square root of 16, which is 4. 4 cubed is 64. You can let your calculator do that all for you. So I have 45 equals 128 over 3 plus C. So if I subtract this in my calculator, I would take 45 minus the 128 divided by 3. And I would remember to use my fraction key in this case, because again, it doesn't round it nice and neat. It makes it actually a repeating decimal. And so my answer here should be 7/3 if you do that correctly. Again, I did 45 minus the 128 over 3 in my calculator, and I used that fraction key to convert it back. So my answer here is cost function is equal to 2/3 x to the 3/2 plus 7/3. So we had one problem where the fixed cost is given to us. That's automatically your C. 15 gave you an actual point with the quantity and cost. You had to plug that in to evaluate for C. Looking at 16. 16 says find the demand function for the marginal revenue function. From it, recall that if no items are sold, the revenue is 0. So remember, for this revenue function, C is always assumed to be 0. We're going to go backwards from this. So a reminder here is that the revenue function we did a long time ago was P times X. P was our price, X was our quantity, but P was also defined to be our demand function. So that's a reminder. The first thing we got to do is take the integral of our revenue function. With respect to x, with a constant, remember we add the x, add 1 to the exponent, divide by the new, add 1 to the exponent, divide by the new exponent, remember the plus c. Always just go ahead and write down, be in the habit. So my revenue function, 175x minus 0.01 x squared minus 0.01 x cubed, and remember C is 0 for revenue, because when you produce anything you do not expect to have any revenue. So this is my revenue function. That's not what it's asking for, but that's important. My demand function comes from up here. Revenue is price times x. The P is my demand function, so we need to take this revenue function and divide it by x. So my demand function, 175 minus 0.01x minus 0.01x squared. This is not a new idea. We did it a long time ago, so this is a good reminder. So some pieces that you need to keep bringing back, which is helpful as well for the final exam. So one more. Again, pause it anytime you need. 17, marginal profit of a small fast food restaurant given in thousands of dollars. That's important. Here's my profit function, or sorry, my derivative of my profit function. X is in sale volumes in thousands of hamburgers. My profit is a negative 1,000 when no hamburgers are sold. So just as a reminder, the C for a profit function is always a negative the fixed cost. So this actually tells me my fixed costs were $1,000. That's just helpful because it's going to be presented to you in a different format. So in this case, it's telling you what C is, but know that that's related to the actual original cost function as well. So we're going to start off by taking the integral, and I'm going to rewrite it in the form that I can use the power rule on. So P of x, add 1 to the exponent, divide by that exponent. If it's a constant, you're adding an x. Remember the plus C. I made an error when I was making a statement before. I want to clarify that. The profit is a negative 1,000 when no hamburgers are sold. So normally we would have thought of this being a negative 1,000, but this is where you got to be careful. This is actually, again, where we have to go back and look at our units. And our profit is in thousands of dollars, so we're not going to use the negative 1,000. It's actually a negative 1. So be careful when those units are given to you in this case. The fixed costs are $1,000, but again, relating it here, the actual answers that are coming out in thousands of dollars, so we need to use a negative 1. So my answer for my equation, flip the 2/3, should be a minus 1 in that case. Be very careful. I made that mistake originally. I was just, again, reading it and not slowing down and looking at my units. And that's also how they present that piece. In this case, again, you have to look back at your units when you are using your C and plugging in. For revenue functions, C is always 0. For cost functions, it is always the fixed costs, but sometimes they'll give you a point instead. For profit functions, C will always be a negative fixed cost. Make sure you write those down so you have those memorized come test time. It might be a great idea to data dump those pieces as well.